Okay, we're in the Haas mill programming workbook, and we are doing the interpolation exercise here. Excellent beginning project. And we have it set up in our Haas machine. We're actually going to do the thing for real right here. Daniel's testing it out. We did the G13 exercise yesterday. We realized the interpolation exercise uses the same size material. We just happen to have some big pieces. So we're actually going to cut the profile around the outside here with the 1/2" end mill as specified. Now we know on our feeds and speeds that it was very conservative. So we went to 3,000 RPM. Here we get a feed rate of 50 inches a minute plunging and then 12 inches a minute going around. Other than that, I think the 50 inches a minute, let's see, that might plunge into the material. We're going to change this feed rate right here. Change that to 10. Alter, okay. Alright, good. So you just take out the 2-inch shift, the dry run shift right there. Yep. We did dry run it in the air. We're using tool number 1 with no geometry offset because it's linear at center of tool programming. It's pretty similar to what CAD cams come out with. Alright, do your graphics exercise. Just reset. Memory reset, so stop in the beginning. Yep. And take a single block off. Alright. So it works there. You already ran in the air, so now we're going to run it for real. Alright. So what we do there, we go distance to go on the position coordinates and check. Alright. And coolant, we should turn the valve on. Alright. There we go. Alright. So what's our distance to go say on single block, right? Minus 0.4099. That looks, yeah, it looks about right. All right, finish that one. All right, now let's switch to position G54, right? So that should be 0.100 above the part. Turn the coolant off for a second. And that looks correct. All right. What's our position, actual position? Negative 0.25, positive 0.25. Looks kind of far away. No, maybe it is right. Yeah, it looks about right. Yeah. Okay, coolant back on. Shut the doors. Hit clockwise on the spindle to get it up to speed. Alright, let's take the single block off and we'll let it cut. Just be on the feed hole button if you hear anything funny. Is that torque, by the way? You torque that? Yeah. Yeah, because we didn't shift it into the material, which should be expected. And when it starts going around the corner is when you start hearing the cutting.
Yeah.
Hit feed hole for a second. Alright. How's that cutting? Is cutting okay? Alright. Hit cycle start again. What's the load meter say? 50%? Okay. It's kind of a heavy cut.
I think the feed rate's slow.
Yep. Hit feed hole for a second. Alright. Let's just reduce the feed rate by 50% just to be first time around. Okay. Continue on. That's like a full slot right there. So we're not doing any roughing. We're just going right for finishing. Got good flood coolant. 55% load. Big chips. little bit different than when we're cutting with Fusion 360. And it should be, and it should do the G2 move right there, the G2 counterclockwise. G1 to the outside and then G1 back up to the starting position. Now you can put it back to 100% feed. You want to reduce it on that full slotting area. Alright, and it goes back home. What's the home command? The old home command is G28 G91Z0, just like what Dorothy says. So, all right, let's blow that off. Let's take a look. Oh, there we go. Like the book. So we have that, and we've done. This is page 55. This is the G12 section right here. So we're up to that part right now. And later on we're going to do the can cycle, which is the drilling cycles. All right. Thanks a lot, Daniel.